All right, I've gathered together some of the important information we have where we have vertical tangent lines and horizontal tangent lines. I've got a plot of theta versus the radius, so the angle versus the radius, which we can use to help construct this graph, and I've got some graph paper. Okay, so we've got just a couple of important points marked on this graph to get started with. Let's plot them. So at angle 0, we are out here at a radius of 2. At angle pi over 2, we are distance 1 from the pole. At pi, we actually are right up in there. We're on the pole. At 3 pi over 2, we are again distance 1 from the pole. And at 2 pi, we are back to where we started. Okay. Now we should look at these multiples of pi over 3, since those are important points in terms of derivatives. Okay, so r at pi over 3 is 1 plus cosine of pi over 3, which is 1 plus 1/2. So that is, we're at angle pi over 3, and we're distance 1.5 from the pole, and we have a horizontal tangent line across like that. Okay, if we look at r of 2 pi over 3, this is 1 plus cosine of 2 pi over 3, which is equal to 1 minus 1/2, okay, or 1/2. And at 2 pi over 3, we have a vertical tangent line. So, drawing him in there, let's give him a vertical tangent line. Okay. At r of 4 pi over 3, again, this is equal to 1/2. And r of 5 pi over 3 is again equal to 3/2. So we can draw these guys in. This is showing symmetry between the two graphs. So at 4 pi over 3, we have distance of 1/2. From our center, and oops, we can draw a little vertical tangent line. At 5 pi over 3, we have distance 1.5 from our center, and we have a little horizontal tangent line, like that. Okay. And at pi, we're supposed to have a little horizontal tangent line, like that. Okay, so we can start to fill this guy in. So if we draw him in, we see this cardioid, dun, 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 tangent, where we're supposed to be tangent, okay, up, in for our heart, and around tangent, where we're supposed to be tangent. All right, and here we can see our cardioid. So you can see that having the derivative, especially where it's 0 or horizontal, can help us fill in our plot. Of course, graphing applications are really important and helpful if we want to graph polar curves like this. And finally, I thought we should do just a little bit more practice of writing things using polar coordinates. This has the form r and theta. So let's just write down some of the points that we have plotted. So we started it with the point 2, 0. We plotted 1.5 pi over 3, and then 1 pi over 2. Then 1/2 2 pi over 3. And 0 pi. Then we had 1/2 4 pi over 3. And 1 3 pi over 2. And 1.5 2 pi, or rather 5 pi over 3. And finally 2 pi. You can see here that we have this nice symmetry. Notice that since 1 plus cosine theta is symmetric, we're going to have symmetry across this polar axis. So if I draw in a line crossing that polar axis, it doesn't matter whether we started by looking at points rotating up from the polar axis or down, so clockwise or counterclockwise. We're going to be plotting the same points. So that symmetry we can see in this equation. Okay, so keep your eyes peeled for things like that. Great.